Hi guys, today we're looking at solving equations where x is the index. Our learning intention for today is to be able to solve equations where x is the index when in quadratic form. Okay, let's look at an example question. This is question 9. That's question 9, part 1. Solve the equation 2 to the power of x plus 2 squared minus x equals 5. When solving these types of equations, the first thing you must do is bring all terms to one side of the equation. This gives us 2 to the power of x plus 2 squared minus x minus 5 equals 0. From here, we let y equal 2 to the power of x. So wherever I see 2 to the power of x, I want to substitute in for y. This will give me a quadratic equation which I'll be able to solve. In order to substitute in y for 2 to the power of x, we must use our indices rules to write each term as 2 to the power of x. So let's look at our indices rules and see how we can manipulate our equation. So this 2 to the power of x is fine. However, we must separate our second term here so that it is written as 2 to the power of x times some other term. Our second rule of indices state that a to the power of p divided by a to the power of q is the same as a to the power of p minus q, i.e., when you are subtracting two indices, it is the same as dividing out two values that have the same base. Therefore, our second term can be written as, if we have 2 squared minus x, this can be written as 2 squared over 2 to the power of x. This gives us 2 to the power of x plus 2 squared over 2 to the power of x minus 5 equals 0. From here, I substitute in y for 2 to the power of x, and I get y plus 4 over y minus 5 equals 0. I now want to solve for y. Well, the first thing I notice here is that I have a fraction, and you know that we hate fractions. Therefore, we're going to get rid of our fraction first by multiplying every term by our denominator y. So multiplying every term for y, I get, so I'm just going to multiply everything by y here. So I get y times y, which gives me y squared, plus 4y over y, which leaves us with 4, minus 5 times y, which gives us 5y. Therefore, we have y squared plus 4 minus 5y equals 0. We now want to solve for y. To do this, I'm going to rearrange my equation so it's written in the form of ay squared plus by plus c. To solve for y, I must factorize my equation. I need the factors of my n values that add to make my middle value. The factors of 4 that make minus 5 are minus 4 and minus 1. This gives us y minus 4 and y minus 1 equals 0. I now want to solve for y, so I put both brackets equal to 0 and solve. This leaves us with y is equal to 4 and y is equal to 1. Don't forget that this question is asking you to solve for x. We find the value for y, so now we substitute it into our equation y is equal to 2 to the power of x and solve for our x exponent. This gives us 4 is equal to 2 to the power of x. To solve for x as an exponent, both terms must have the same base. 4 is the same as 2 squared. 2 squared equals 2 to the power of x. To solve for our exponents, we put our indices, we equate our indices, and we get 2 is equal to x. We now must solve for our second value of y. This gives us 1 is equal to 2 to the power of x. To solve for x, our exponent, we must write both terms with a common base. 1 is the same as writing 2 to the power of 0. This means 2 to the power of 0 is equal to 2 to the power of x, and 0 is equal to x. Let's try another question. This is question 8, part 3. 2 to the power of x plus 2 to the power of minus x is equal to 17 over 4. The first thing we must do is bring all terms to one side of the equation. This gives us 2 to the power of x plus 2 to the power of minus x minus 17 over 4 equals 0. From here, I want to let y equal 2 to the power of x. And wherever I see 2 to the power of x, I must substitute in y. So we can see our first term, we can just substitute it straight in. However, our second term is 2 to the power of minus x. So we need to use our indices rules to write each term as 2 to the power of x. Our indices rules state that a to the power of minus p is the same as writing 1 over a to the power of that positive exponent. This means that 2 to the power of minus x can be written in the form of 1 over 2 to the power of x. This leaves us with 2 to the power of x plus 1 over 2 to the power of x minus 17 over 4. We now substitute in y for 2 to the power of x. This gives us y plus 1 over y minus 17 over 4 equals 0. We now need to solve for y. The first thing I see is that I have two fractions. So you must first get rid of your fractions. To do this, I'm going to multiply each term by my denominators. Let's start with our y. So I'm going to multiply each term by y, i.e. multiply your whole equation by y. This gives me y times y, which is y squared. 1 times y gives me y over y, minus 17y over 4. This simplifies to y squared plus 1 minus 17y over 4. From here, we still want to get rid of our fractions. So I'm going to do the same thing again with my second denominator of 4. So I'm going to multiply my whole equation by 4 now. This gives me 4 times y squared equals 4y squared. 4 times 1 gives me 4, minus 4 times 17 over 4. And your 4's cancel out in that case, which leaves us with 17y. This gives us 4y squared plus 4 minus 17y equals 0. I now want to solve for y, so I need to solve for this trinomial equation. The first thing I'm going to do is rearrange my equation so that it's in the form of ay squared plus by plus c. So we just want to put this term here in the middle. This gives us 4y squared minus 17y plus 4 equals 0. I now want to solve for y, so I'm going to factorize my equation. So I'm going to times my n values and find the factors of 16 that can add to make minus 17. This gives us 4y minus 1 times y minus 4. I now want to solve for y, so I put both brackets equal to 0 and find y. Y is equal to 1 over 4 and y is equal to 4. Now don't forget that this question is asking us to solve for x. So we now have to substitute our values for y into our equation y is equal to 2 to the power of x and solve for x. 1 over 4 equals 2 to the power of x. To solve for our exponent, we must have both terms written with a common base. 4, our denominator, can be written as 2 squared. Therefore, 1 over 2 squared equals 2 to the power of x. And 1 over 2 squared can be written as 2 to the power of minus 2. So any exponent that's on your denominator can be written on the numerator by changing the sign. This gives us 2 to the power of minus 2 equals 2 to the power of x. Minus 2 is equal to x. We also need to solve for when y is equal to 4. This gives us 4 equals 2 to the power of x. 4 is the same as writing 2 squared, so we rearrange 4 to write it as 2 squared so that we have a common base. And equating our indices gives us 2 equals x. Let's try another question. Let's look at question 9, part 5. 3 to the power of 2x plus 1 minus 4 to the power of 3x, 4 times 3 to the power of x, plus 1 equals 0. We want to solve for x, so the first thing we need to do is bring all terms to one side of the equation. To solve for x in this case, we need to let y equal to 3 to the power of x and substitute in 3 to the power y for 3 to the power of x in our equation. However, we must first use our indice rules to write each term with 3 to the power of x. We can see that our middle term here is fine. However, our first term needs to be manipulated so that it is written in terms of 3 to the power of x. How can we do this? Rule 1 states that a to the power of p plus q is the same as a to the power of p times a to the power of q. This means that 3 to the power of 2x plus 1 is the same as writing 3 to the power of 2x times 3 to the power of 1. We can manipulate this further. We also know that Rule 3 states that a to the power of p times q is the same as a to the power of p all to the power of q. This means that 3 to the power of 2x is the same as writing 3 to the power of x all squared. This leaves us with 3 to the power of x squared times 3 to the power of 1 minus 4 times 3 to the power of x plus 1 equals 0. Substituting in for 3 to the power of x as y, we're left with 3y squared minus 4y plus 1 equals 0. And from here, we want to solve for y, so we're going to factorize our equation. So what are the factors of our n values? That's 3 times 1, 3, which add to make our middle value of minus 4. Our factors are 3y minus 1 and y minus 1. To solve for y, we put both brackets equal to 0. This leaves us with 3y minus 1 equals 0 and y minus 1 equals 0. Solving for y, we have y is equal to 1 over 3 and y is equal to 1. We have now found the values of y. So step 6, we must use our values of y to find x. Y is equal to 3 over x. So substituting in our values for y, we get 1 over 3 equals 3 over x. To solve for x, we must have a common base. 1 over 3 is the same as 1 over 3 to the power of 1. And any exponent on our denominator can be written on our numerator by changing our sign. So 1 over 3 to the power of 1 becomes 3 to the negative 1. This is all equal to 3 to the power of x. And minus 1 is equal to x. Solving for our other value of x, we have 1 is equal to 3 to the power of x. To solve for our exponent, we must write both terms with a common base. 1 can be written as 3 to the power of 0. This is all equal to 3 to the power of x. Equating our exponents, we have 0 equals x.